good morning dear students. So today we are going to discuss our next topic, that is the mole concept in terms of molecules. So until now we have discussed the mole concept in terms of atom and we try to derive all the relationships. Hope you remember. Now we are going to learn the mole concept in terms of molecules actually. So I hope you remember my initial lecture where I have told like mole is a term that can be used with anything actually. You can consider this similar to our dozen. I told, right, if I say 1 dozen pen means 12 pen, 1 dozen egg means 12 egg. So every time this dozen is used with a different terms. One time it is egg, one time it is pen. Similar to that, mole can be used with anything actually. So since we are learning chemistry, we will be learning mole concept in terms of atoms, mole concept in terms of molecules, mole concept in terms of electrons, protons and neutrons, mole concept in terms of ions. These are the main things you need to learn. Okay, so next we are going to discuss mole concept in terms of molecules. Now here, what is a molecule first? You know that atoms combine together to form molecules. So every time we cannot say how many atoms can combine to form one molecule. It varies between different atoms. For example, in the case of hydrogen, I can say 2 hydrogen atoms combine together to form one molecule of hydrogen. And also oxygen molecule, we can say 2 oxygen atoms combine together to form one oxygen molecule. But in the case of ozone, we can say 3 atoms of oxygen combine together to form one molecule of ozone. So generally speaking, atoms combine together to form molecules. Then one important doubt will come to mind. Sir, why the atom should combine? Why can't it exist as atom itself? The reason for that is to attain stability. So why it combines? To attain stability. How it is attaining stability? All these things are discussed in the chapter chemical bonding, where it will discuss why a chemical bond is being formed to attain stability. So the answer for that all lies in the chapter chemical bonding. I am not discussing those things now. Just now I am discussing what is molecules, how mole concept can be explained in terms of molecules. Okay, so first we will write the basic definition, mole concept for this one. Then we will come to the concept. I will explain that. Okay, I hope you could see the board now. So please understand here. We are mainly going to discuss the mole concept in terms of molecules. Now how it differs from mole concept in terms of atom? Only one point it will differ, that I will explain. So right now you could see here 1 mole of, I have taken example as oxygen. So you can see here 1 mole of oxygen molecule will contain, so since it is the number of molecules, we say will contain, okay. 1 molecule of oxygen molecules will contain how many number of molecules? 6.023 into 10 power 23 oxygen molecules. And 1 mole of oxygen molecule has a mass of, how much mass it will have? It will have molecular mass in grams, because earlier it was atom, that's why atomic mass we say that should be expressed in grams earlier. Now we say it is molecule, so we say molecular mass in grams. Example, here oxygen is taken, so oxygen has a molecular mass of 32. Since it should be expressed in grams, we say 32 gram. Okay, and this is equal to what? Earlier it was 1 gram atom, now I can say 1 gram molecule. Again it is a single term, gram molecule is a single term. Okay, and one more extension is here compared to the number of compared to the atoms. Here you could say it is occupying 1 mole of any oxygen molecule or any substance will occupy what? 22.4 liter at the STP. So what is STP? Standard temperature and pressure. So what is that value of standard temperature? We can have that value of temperature as 273.15 Kelvin and pressure as 1 atmosphere. So what does this mean? Then one doubt will come, sir, why this volume was not there in atoms? Because most of the atoms will never exist as gas actually. Molecules, atoms combine together to form molecule, and they will be mainly in the form of what? Gaseous form. Oxygen is in gaseous form, nitrogen, hydrogen. So that's why we are also saying what is the volume, 1 mole of that substance, how much volume it will occupy. And you can ask here, sir, why STP is there? Because we know that gases, it can be compressed and it can be expanded. and also the gases, how much space it occupy, that will vary with the temperature and pressure based on the equation PV is equal to nRT that we will learn in the chapter states of matter. Okay, so so that what is the conclusion then? I can say that gases, if you want to measure the volume of the gases, you should fix these things. You should fix the temperature and pressure. Then the question will come, sir, what temperature, what value of temperature and pressure we will fix? That is why they have come up with standard values. That is why standard value of temperature and pressure. Temperature I told 273.15 Kelvin and pressure I told 1 atmosphere. At this temperature and pressure, 1 mole of any substance, please understand, 1 mole of any molecules, it can be any molecules, it can be oxygen molecule, it can be nitrogen molecule, it can be hydrogen molecule, whatever be it, it will occupy what volume? 22.4 liter, easy. That's why I am telling 1 mole of any substance at STP, that is very important. If it is not standard temperature and pressure, we cannot say it is 22.4 liter. If it is standard temperature and pressure and if it is 1 mole of the gas, then I can say it will occupy how much volume? 22.4 liter at STP. How this is coming at that and all I will explain in states of matter. So what are the extensions now you could, what are the dimensions now you can give in terms of molecules? Please think, 1 mole of any molecules, tell me, will contain how many molecules? 6.023 into 10 power 23 molecules. And it will have a mass of molecular mass in grams, and that is equal to 1 gram molecule, and 1 mole of this molecule will occupy a volume of 22.4 liter at STP. Now you can think like, as I explained earlier, how many questions can be derived out of this concept. Now you know that between these two, okay, again I am putting bidirectional arrow. Now you know why I am putting bidirectional arrow. 2 questions can be derived out of this. So that means 2 will come here. Now another 2 questions can be derived from these 2. Correct? So again 2 questions will come here. Now again 2 questions can be derived from these 2. So how many will come? Another 2 will come. And again 2 questions can be derived to here. So again 2 will come. Now how much? 2, 4, 6, 8. Now you know that between these 2 questions can be derived. So again 2 questions, and between this and this 2 questions can be derived. Again 2 questions, and between this and this 2 questions can be derived. Again 2 questions. Correct? Now between this and this 2 questions can be derived. Correct? Now between this and this 2 questions can be derived. Correct? That is also over. Now last thing, between this and this 2 questions can be derived. So tell me, what are the maximum possible questions when 5 combinations are there? You can see here, I can add 2 plus 2 4 plus 2 6 plus 2 8 plus 2 10 plus 2 12 14 16 18 20. Understood? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I can say a total of 20 questions can be derived from the mole concept in terms of molecules. So if you know how to derive this question and how to do this, it's very easy. No questions will come outside of this. Understood? So this is the fundamental concept you should remember. So one more time I am explaining, very simple. 1 mole of any substance, 1 mole of, not any substance, 1 mole of molecules, any molecule will contain Avogadro number of molecules, 6.023 into 10 power 23 molecules, and this will have a mass of molecular mass in grams, and this is equal to 1 gram molecule, and this will occupy a volume of 22.4 liter at STP. Understood? So this is also called molar volume. Why it is they are saying molar volume? Because the volume occupied by 1 mole. Volume occupied by 1 mole is called molar volume. And also sometimes molecular mass in grams is also called as molar mass. Please understand, molecular, it is not molecular mass which is called as molar mass. It is the molecular mass in grams is called as molar mass. That means mass occupied by 1 mole of the substance. We can replace molecular mass in grams with the molar mass also. That is also correct. And here you know what is molar volume? Volume occupied by 1 mole of that substance, that is called molar volume. Okay, so I hope you understood this concept. Now we will try to derive the questions, and then we will learn the questions one by one, and then we will go to the next topic. Okay, I hope you are able to read the question now. Calculate the number of moles of O2 molecules present in 6 into 10 power 24 molecules of oxygen molecules. So they are asking me number of moles, and what they have given? They have given the number of molecules. So tell me how to do this. Please think about the same way we have done in the case of atoms. So I know my fundamental relationship. What is my fundamental relationship? First question answer. I know that 1 mole of O2 molecule, 1 mole of O2 molecule will contain 6.023 into 10 power 23 molecules of oxygen. Correct? This is the fundamental relationship, I know. I think you have just seen that. Okay. Now, they are asking you to calculate the number of moles. So I will put the question mark here. And number of moles in what they are asking? They are asking to calculate the number of moles in 6 into 10 power 24 molecules of oxygen. Molecules of oxygen. This is what they are asking me to calculate. And you know the method, how to do this. Now first I need to think how I can convert 6 into 10 power 23 to what value? 6 into 10 power 24. So I have told you initially also how to do that. Either you can convert this into one molecule. How to do that? Divide by 6.023 into 10 power 23. So it will become 1. So when you do it on the RHS, do it on the LHS also. Once it is getting converted into 1, then you can convert that number to any number. So for example here 6 into 10 power 24. Multiply by 6 into 10 power 24 on the RHS. Same thing you do it on the LHS. This is the classical method. But here if you see 6 into 10 power 23, how it can be converted into 6 into 10 power 24? If I just multiply with the 10, this will become 10 power 23 into 10 becomes 6 into 10 power 24. Don't think about 6.023 that we are approximating. Okay. So multiply by 10. So on multiplying by 10, this will get converted to this one. So when you multiply on the RHS by 10, multiply here also by 10. So this will become what? 10 mole. 10 mole of O2 molecule. So my answer is what? 10. Because 6 into 10 power 24 molecules of oxygen will contain 10 moles of oxygen molecules. Understood? So this is the way we need to do this type of questions. Now we will do the second question derived out of this. Okay, now read the question. Calculate the number of oxygen molecules present in 0.1 mole of oxygen molecules. Now if you read the question thoroughly, I could understand what are the terms to be related. The number of molecules. Understood? Present in 0.1 mole, that is between the number of molecules and number of moles. So what is given here? Number of moles is given here. So they have given in 0.1 mole of O2 molecule. Correct. They have given this. And what they are asking you to calculate? The number of O2 molecules. So this is what I need to find it out. Okay. Now you can itself think like we know our fundamental relationship. 1 mole of O2 molecule will contain what? 6.023 into 10 power 23 oxygen molecules. Okay. So now tell me how to find this. How to convert 1 mole to 0.1 mole. What should be done? So you know that it should be divided by 10 to convert this into 0.1. So I will divide by 10 here. So when you divide by 10 here, you should also do the same thing by here also. Divide by 10. So when you divide by 10, this will become 6.023 into 10 power 22 molecules of O2. So I got my answer. So 0.1 mole of oxygen molecule will contain 6.023 into 10 power 22 molecules of oxygen. They can ask 0.2 also. So what you should do? How can you convert 1 into 0.2? Multiply by 0.2. Understood? So multiplying by 0.2, here also you should multiply by 0.2. You will get the answer. So this is very easy. I hope you are understanding this. Now we will try to derive the relationship between the next two terms, or we will derive the questions, that is between the number of moles and molecular mass in grams, or mass in grams. Okay. So I am concluding here. I hope you understood this lecture. Okay. So good morning students. So welcome you all for today's lecture. So today we were doing the topic mole concept in terms of molecules. I hope you remember. Okay. So in the last class we have discussed the various formulas regarding that, and now we need to derive the other questions that came out of the relation. Okay. So today we are going to relate between the number of moles and mass in grams. Okay. So here, so as discussed earlier during the discussion on the mole concept in terms of number of atoms, here also you can see here which all terms I am trying to derive. Okay, calculate the number of moles. Okay, so I want one of the term as number of moles, and number of moles of oxygen molecules present in 2 grams of oxygen molecules. So that means the relation between number of moles and mass in grams. Correct. So tell me, what is the fundamental relationship? We know that with respect to number of moles, we know the fundamental relationship. 1 mole of any molecule, here which is the molecule? Oxygen. So I can write 1 mole of oxygen molecule have a mass of, okay, because I don't want to relate between the number of molecules here. Here the relation between number of moles and mass in grams. So I know 1 mole of oxygen molecules is equal to molecular mass in grams. So here what is the stuff? Oxygen. So I know that. Please listen here how it differs from atomic formula. Here molecule we are speaking about. How oxygen exists as a molecule, whether it in the form of O? No, we know that 2 oxygen atoms combine together to form an oxygen molecule. So it will be O2. So molecular mass will be how much for O2? I can say that for O2 the molecular mass will be 16 into 2, that is 32 grams. This is very important. So in exams also, please understand, if they are speaking about oxygen atom, never take 32, then it is atomic mass, then it will become 16 gram. Now we are speaking about oxygen molecules, that's why 32 gram is coming into picture. Okay, please understand that. Okay, so this is what we know as the fundamental formula. Okay, so now what we need to do, they are asking you the number of moles. So the number of moles means, here I will put the question mark. Number of moles of oxygen molecules in how much grams they are asking? 2 grams of oxygen molecules. So this 32 gram I should convert this to 2 gram. Okay, again I am saying there are 2 methods. First you find it for 1 gram, then multiply by 2 so that you will get it, or otherwise directly convert 32 to 2 gram. Okay, so what can be done here? Tell me how to convert 32 to 2. You know that 32 can be divided by 16 so that it will become 2. Okay, so I am dividing by 16 here. So this will become 2 gram O2 molecules. So when you divide by 16 on the right hand side, you can do the same thing on the left hand side also, that is divide by 16. So my answer will become 1 by 16 mole of O2 molecules. Okay, so I got the answer. So what is the answer? 2 gram of oxygen molecules will contain how many moles? 1 by 16 mole of O2 molecules. Usually they will give it in the form of 1 by 16, else you need to convert this into decimal format, that you know, I hope. Okay, so I hope this is clear. Now also analyze what is given here. They have given you the mass in grams and asked you the number of moles. So in the next question what will happen? They will give you the number of moles and ask you to calculate the mass of that. Okay, that is what we are going to do next. Okay, I hope now you can read the question. Calculate the mass in grams of oxygen molecules present in 0.25 mole of oxygen molecules. Now again please think what is the relationship, mass in grams, okay, and next one is number of moles. So this the equation remains the same. So what is given here, they are asking you the mass in grams. So here I need to put the question mark here. And what they have given here, 0.25 mole. So I anyway usually when a 0.25 comes I used to put there 1/4. That is the easiest way to remember for me. So they have given 1/4 mole of O2 molecules. Okay, 1/4 mole of O2 molecules. Now tell me, this is they have given and they are asking you 1/4 mole of oxygen molecules will have what mass? This is my question. So tell me how to convert 1 to 1/4. You know that, divide by 4. Okay, so 1 when divided by 4 it will become 1/4. Some people say sir multiply by 0.25. Both are correct. So 1 divided by 4. So do the same thing on the right hand side. So divide by 4 here. So this will become 32/4. We know that that is equal to 8 grams of O2 molecules. Okay, so this is very clear. So you could understand that is 1/4 mole of oxygen molecules will have a mass of 8 grams. That will be my answer. So I hope you understood how to convert this between these two. That is the relationship between the number of moles and mass in grams. Okay, so next we will try to derive the relation between the number of moles and gram molecules. Okay, so the next topic is the questions derived out of number of moles and gram molecules. Okay, next relationship. So what is the basic fundamental formula for that? I know that again 1 mole of any molecule, but here it is oxygen given. So I can say 1 mole of oxygen molecule is equal to how many gram molecule? Tell me, you know that it is equal to 1 gram molecule of oxygen molecules. Correct. So this is the fundamental relationship. So now read the question. Calculate the number of moles of oxygen molecules present in 0.5 gram molecule of oxygen molecules. So they are asking you the number of moles. So this is a question mark. Correct. And what they have given? They have given or they are asking you to find out 0.5. How many moles of oxygen are present in 0.5 gram molecule of oxygen. Okay, so again tell me, you know that here number of moles they are asking you to calculate, and what they have given, the number of gram molecules they have given. Correct. So tell me how to convert 1 to 0.5. You need to multiply by 0.5. So when you do it on the right hand side, when you multiply by 0.5, the same thing you can do it on the LHS also. Multiply by 0.5 so that it will become 0.5 moles of oxygen molecules. Correct. So what is my answer? 0.5 gram molecules of oxygen will have 0.5 moles of oxygen molecules. Very easy. Understood. So what will be the next question? Now they are asking you to calculate the number of moles of oxygen molecules. So in the next question, they will be asking you to calculate the number of gram molecules. What they will give? The number of moles they will give. Correct. So we will see that next. Okay, now you could see the question here. Calculate the number of gram molecules of oxygen molecules present in 3.5 moles of O2 molecules. So they have given 3.5 moles of O2 molecules. Okay, and they are asking you to calculate the number of gram molecules in that. Okay, now tell me how to convert 1 to 3.5? So some students uses are 7 by 2. Okay, don't do that. It's better to multiply with 3.5 itself. So multiply by 3.5. So when you multiply 1 with the 3.5, you will get this. So you can do the same thing on the right hand side. What you need to do? It should be multiplied by 3.5. So again, you know that 1 into 3.5 is 3.5 gram molecules of O2 molecules. Usually we don't want to do this question because it is a one-to-one relationship, correct? Because 1 mole will always have 1 gram molecule. So if they say 5 mole, how many gram molecules are present? Answer will be 5 gram molecule. If they reverse, they are asking 5 gram molecule will have how many moles, means again it is 5 mole, because it is 1 mole and this is 1 gram molecule. It is a one-to-one relationship where 1 mole of oxygen molecule will always have 1 gram molecule. In those cases, you don't want to do this also. Without this, you can find it out. But just for your understanding, I am explaining this also. Okay. So I hope the two questions are derived out of this relationship. That is the number of moles and number of gram molecules. Next, what and all things we need to relate between the number of moles and volume at STP. That is 22.4 liter. And you know that is always fixed. Correct. So we will try to derive that. So the next session, so you could see here the questions derived out of number of moles and molar volume at STP, that is always a fixed value, that is 22.4 liter, or even we can say sometimes people used to say 22400 ml, that is also correct, because when you convert this into milliliter, multiply by 1000, that's why 22400 ml. In question paper they will give that also, so you can do it in that. I will show you the questions. Now read the question. Calculate the number of moles of nitrogen molecules present in 44.8 liter of nitrogen gas at STP. Very, very important here. Suppose in the question, if they are not saying STP, will you be able to do this question? I will say surely not, because you don't know even at whether at other temperature and pressure what is the fixed volume. We don't know. The fixed volume of 22.4 liter for any molecule of gas is applicable only if you measure that at standard temperature and pressure. If you have any other standard temperature and pressure, that volume will vary. Understood? So in this question, they should mandatorily they should say at STP. Very, very important if they are asking volume. Okay. So we will try to see the relation. So what is the relation? Tell me. So between whom and whom we need to find the relationship between the number of moles. So I know that 1 mole of any molecule. So here it is nitrogen. 1 mole of nitrogen molecule. Okay. So here we say use the term occupy since it is volume. 1 mole of nitrogen molecule will occupy. Always we know that it is 22.4 liter. We say this as the molar volume. Always mention this is at STP. Okay. So this is the fundamental relationship. Now in the question, what they have given and what they have asked you. So they are asking you calculate the number of moles. So this is what they are asking you. So I am putting question mark there. And what they have given, they are asking you, what they have given is 44.8 liter. 44.8 liter of N2 gas. We will say that also. Okay. N2 gas. So they are asking you indirectly, if you take 44.8 liter of nitrogen gas, how many moles of nitrogen will be present in that? And I know the fundamental relationship, 1 mole of nitrogen gas will occupy a volume of 22.4 liter at STP. Or I can say it in reverse way, 22.4 liter of nitrogen gas has 1 mole of nitrogen molecule. That is also correct. Now tell me how to convert 22.4 liter to 44.8. I have given an easier value here. They can ask for 1 liter, they can ask for 2 liter. So whatever be the case, what you should do here, 22.4 liter should be converted to 1 liter. Then multiply by the number you want. So here it is direct. What you should do, 22.4 should be multiplied by 2 to get 44.8. So I am multiplying by 2 on the RHS. So the same thing you can multiply on the LHS also. So multiplying by 2. So I will get it as 2 mole of nitrogen molecule. So what is my answer? Calculate the number of moles of nitrogen molecules present in 44.8 liter. I know that 44.8 liter of nitrogen gas has how many moles? 2 moles of nitrogen molecules. Okay, so I am also extending this example for you to make you more understandable. So suppose in the question, instead of 44.8 liter, okay, suppose they think like they have asked a question like they want to find you with 0.5 liter. Okay, this is a new question. Don't think it's a older question. It's a new question. Now in this question they are asking you calculate the number of moles of nitrogen molecules present in 0.5 liter of nitrogen gas at STP. What you need to do in this case, again this is what you need to find out, and they have given you this as 0.5 liter. So 0.5 also, I think it's very easy value. What you should do to get 0.5 here, it should be multiplied by, or it should be divided by 11.2. So this 11.2, I think it can be easily converted to 0.5. But think like you don't know what is the, how to get that 11.2, you don't know. What you will do in this case? So first what you need to do is, you can convert this to 0.5. For that what you need to do, convert this value to 1 liter. How you can do that? Divide by 22.4 on both sides. So divide by 22.4 on both sides. Divide by 22.4. Now what will happen when you divide by 22.4? We know that this will become 1 liter of N2 gas at STP. So and what will happen, this will become 1 by 22.4 mole of N2 gas. So please understand now it is telling that if you take 1 liter of nitrogen gas at STP, it will contain how many moles? 1 by 22.4 moles of nitrogen gas. So suppose in exam they are asking you to calculate in 1 liter, you can do like this. But in now the question they are asking you to find it in 0.5 liter. So now tell me, 1 can be converted to any number, whatever number they are asking. Now they are asking 0.5 liter. What you should do? Multiply by 0.5. So I am multiplying by 0.5. So this will become 0.5 liter of N2 gas at STP. Okay. So when you do it here, do the same thing on here, over here, multiply by 0.5. So multiplying by 0.5, what will happen? So we know that 1 by 22.4 into 0.5, that is 1 by 22.4. Okay. Into 0.5. 0.5 is nothing but 1 by 2 mole of N2 gas. So this factor is my answer then. So 0.5 liter of nitrogen gas will have how much mole? 1 by 22.4 into 1 by 2. So this you can calculate it. This will come around 1 by 44.8. Understood? You can do that decimal conversion, you can do it. So please check whether it is correct. 1 mole contains 22.4 liter. They have asked you to find out 0.5 liter. For that I converted this 22.4 liter to 1 liter. How I am doing that? By dividing by the same number. So dividing by 22.4 on both sides, this will become 1 liter. On dividing on this, it will become 1 by 22.4. But I want to find the number of moles not in 1 liter, I want to find in 0.5 liter. So I am multiplying with 0.5 on both sides. So this will become 0.5 liter of nitrogen gas at STP, and this will become 0.5 into 1 by 22.4. That is 1 by 22.4 into 1 by 2, that is 1 by 44.8 moles of nitrogen gas. So I hope you understood the concept. Okay, so we will derive the next question out of this. So students, I have written the second question that is derived out of number of moles and molar volume at STP. Please read the question. Calculate the volume in liter occupied by 0.75 moles of nitrogen gas at STP. Now listen here, they are asking you to find out the volume here. So this is what you need to find out. So what they have given here, the number of moles they have given as 0.75. So I can write 0.75 moles of nitrogen molecules. Correct. Now tell me, you need to find out in 0.75 moles of nitrogen molecules how it will occupy how many volume, that is what at STP. So tell me how to convert 1 to 0.75. So many will say multiply by 0.75, it is correct, but I will do multiplying with the 3 by 4, both are correct, right? So multiplying by 3 by 4. So here also multiply by 3 by 4. So what will be the answer? 22.4 into 3 divided by 4 liter at STP. Okay, now tell me how to do this calculation. Straightforward, I can say you can try to do the calculation between this and this one. Okay, so 4, how much it will become? 4 into 5, 20. Now 2 is coming, so 5.6 it will come. 4 into 5, 20, then 2, 24, 4 into 6, 24, so 5.6. Now multiply between these two, 6 into 3, 18, 1 will come, 5 into 3, 15, 16. So it will become 16.8 liter at STP. I have one tip to say here. My students, some of my earlier students used to do one thing here. When you have 5.6 into 3 to multiply, what they will do is, instead of doing what I have done, what they will do is, they will just multiply 5 into 3. 5 into 3 is how much? You know that it is 15. And they will multiply, then separately they will multiply 0.6 into 3 or 6 into 3, that is 18. Then 0.6 into 3 means 1.8. Then they will add this 15 with the 1.8, that is 16.8 liter. Some students used to do, just I have told you as a hint. Okay, so I hope you now you understood the relation between these two and how the questions are derived out of this. Now we will derive the questions between what and all things we need to derive. Questions derived out of number of molecules and mass in grams. That is the next part we need to do. Okay, so the next terms to be related is number of molecules and mass in grams. Okay, so the question here is okay, so first of all we will write the fundamental relationship between these two. So between the number of molecules and mass in grams, what is the fundamental relationship? We know that 6.023 into 10 power 23 molecules. What molecules they are mentioning? Hydrogen. So I will take hydrogen. So hydrogen molecules will have a mass of, what is our fundamental saying? Molecular mass in grams. So we know that, please consider here it is not hydrogen atom, they are mentioning hydrogen molecules. So one hydrogen atom means one is the mass, then two hydrogen atom combined together to form single molecule. Then I can say mass is 2 and it should be expressed in grams, molecular mass in grams. So I can say 2 grams, or I should say explicitly like this for initial learning: molecular mass in grams. And who is the element we are speaking about? Hydrogen. So this becomes hydrogen, that means it will become 2 grams. More clear now. Okay, now what they are asking you to find out the number of molecules. So here I will put the question mark. And what they have given, 10 grams of hydrogen molecules. So 10 grams, I can keep it here, 10 grams of H2 molecule. Okay, now tell me how to convert 2 gram to 10 gram. Again, two methods are there: convert this to 1 gram and then multiply by 10. To convert this to 1 gram, divide by 2 first, then multiply by 10. That is a fundamental stuff. But how you can directly do that? You know that 2 into 5 is 10. So you can say that multiply by 5. So when you are doing it on the RHS, do the same thing on the LHS, and I can say that when multiply by 5, so 5 into 6, that is 30. I am approximating it, that's why 5 into 6, 30 into 10 power 23 hydrogen molecules. Okay, sometimes in options they will say 3 into 10 power 24, both are correct. Understood? So please go through the options very thoroughly, then you will get the exact answer. Okay. And even sometimes they can say it in another way. Instead of doing it like this, they may say the options like this also. 3 into 10 power 23, right? So this can be written as you know, 5 into 6, that is 30 into 10 power 23. And this can be further written as, and you know, this is nothing but my Na. That is Avogadro number. So this can be written as 5 Na. So options can also be given like this also. So always be careful while going through the options. Okay, so we will derive the next question out of this relationship. So listen, so next question I have written here. Calculate the mass. Okay, they should have specifically mentioned mass in grams. Okay, so that will become more clear. Calculate the mass in grams of 2 molecules of hydrogen molecules. They are asking you number of molecules as given as 2. Okay, so what is given here? They have given this one, number of molecules. So that is how much? 2. 2 hydrogen molecules. And they are asking you what is the mass of that. Now tell me how to convert 6.023 into 10 power 23 to 2 hydrogen molecules. I know that it is not that easier, right? You cannot directly do that. So what you will do? You will convert this to 1 first. So how to do that? How to convert that to 1? Tell me. Okay, to convert this into 1, what you should do? Divide by 6.023 into 10 power 23. So when you are dividing on the LHS, divide the same thing on the RHS also. Divide by 6.023 into 10 power 23. Okay, so when you are dividing here, this will become 1 hydrogen molecule. Correct. And when you are dividing here, this will become 2 by 6.023 into 10 power 23. Okay. I hope you understood up to this. Now, what do you need to do? Now you know what is the unit here? Gram. Now you know 1 hydrogen molecule will have what the mass in grams. Now you got it. Correct. 1 hydrogen molecule will have 2 by 6.023 into 10 power 23 grams. Or this can even give in the options as how 2 by Na grams. Okay, when you are learning, always it is easier to mention it like this, because we are now building up our concept. We are, rather than focusing on the calculation, we are more focusing on the concept actually. So calculation tips and all I will tell it. Once we are thorough with the concept, I will tell you. Okay, so this is for 1 hydrogen molecule. Now tell me, in the question, are they asking the mass of 1 hydrogen molecule? No, they are asking you with the 2 hydrogen molecule. So how to convert this into 2? Multiply by 2. So do it on the both sides, multiply by 2. So this will become 2 hydrogen molecule, and when you do it on here, this will become 2 into 2, multiplying on the numerator, this will become 4 by 6.023 into 10 power 23 gram. This will be the answer. Now how we can write this as a beautiful answer? Tell me. I can say, if I am doing, I will take it like this. I will take it like 4 by 6. Okay, and I will take the 10 power 23 to numerator, so that it will become 10 power minus 23 gram. And I know that this on calculation, this will become 2, this will become 3, and when you do this, how much it will get? 3 when cut, you will get 0.6. So I can say the answer as approximately 0.6 into 10 power minus 23 gram. Some people do one thing, they will multiply 10 on the numerator and divide by 10. So if you multiply with the 10 on the numerator, it will become 6, and denominator by 10 means that 10 will go up and it will become 10 power minus 24. So this can also be in options, they can give it as 6 into 10 power minus 24 gram. Okay. So different ways of representing your answer, nothing else. So I hope you understood. Now the two questions that I think only right now we have done the two questions, right? So we have done two questions with respect to number of molecules and mass in grams. So this was the second question. Okay. So next we will focus on the next relationship, that is questions derived out of number of molecules and gram molecule. Okay, so next we are going to derive the questions out of number of molecules and number of gram molecules. Now tell me, what is the fundamental relationship between these two? So number of molecules means I can say 6.023 into 10 power 23. Which molecule we are speaking about? Gas. Whenever they say gas, it exists as a molecule, we know. So it is nitrogen molecule. So I can say 6.023 into 10 power 23 molecules of N2 gas, nitrogen gas. Okay, will have how many gram molecules? I know that this is with 1 gram molecule. So I can write 1 gram molecule of N2 gas. Correct. Now we will read the question. Calculate the number of molecules. So they are asking you the number of molecules. Here I can put the question mark. Number of molecules of nitrogen gas present in how many gram molecules? 0.5 gram molecules of nitrogen gas. So they have given here 0.5 gram molecules of nitrogen gas. Correct. Now you can tell me how to do this. So we need to, they are asking you 0.5 gram molecules of nitrogen gas will have how many molecules of nitrogen gas. So how to convert 1 to 0.5? Multiply by 0.5. Correct. So multiply by 0.5. So do the same thing over here, multiply by 0.5. So tell me, when you multiply with 0.5, this will become what? This will become 3 into approximately 3 into 10 power 23 N2 molecules. Correct. So this arrow is not perfect. So I'll say put it like this. Okay. So 3 into 10 power 23 nitrogen molecules. So the answer is 3 into 10 power 23. So sometimes in the options they will give it like this also. Can you say Na by 2? That is also correct. I hope you understood. So we will derive the next question out of the same relationship. Okay. So you could read the second question out of this. Calculate the number of gram molecules of nitrogen gas present in 4 Na molecules of nitrogen gas. So instead of saying the number of molecules directly, they are giving this indirectly as 4 Na. What is 4 Na? Tell me what is 4 Na. For your understanding, I am telling 4 Na means what actually? 4 into 6.023 into 10 power 23. Correct? So this is what they are asking, but they have given in this format. Okay, so like this indirectly also they can give. Okay. So now we know that what they have given is 4 into 6.023 into 10 power 23 molecules of N2 gas. Okay, they have given this and asking you to calculate what is this value. Okay, the corresponding value is what? So tell me what you should do to convert 6.023 into 10 power 23 to 4 into 6.023 into 10 power 23. Tell me, it should be multiplied by 4. So do the same thing on the right hand side, multiply by 4. So the answer will be 4 gram molecule of N2 gas. Okay, so easy, you got the answer very easily. Sometimes they give 2 molecule or 1 molecule or 3 molecule. Then what you need to do, convert this to 1 molecule by dividing the same number, then multiply by the number they have given. That's it. Okay, so I hope you understood the concept, that is the relationship. Two questions are derived out of the relationship between the number of molecules and number of gram molecules. Now tell me, what is the next relationship to be derived? Between the number of molecules and volume at STP, that is a molar volume, that you know it is always fixed as 22.4 liter at STP. That we will do next. Hi dear students, so we are going to discuss today the same topic, that is the mole concept in terms of molecules, but here we are now going to derive the relationship between, or the questions derived out of the number of molecules and molar volume at STP. Okay, questions derived out of this. Again, you know that how many questions can be derived out of this relationship? 2 questions can be derived. So first we will read the question, based on that we will try to find out the answer. Okay, so here read the question. Calculate the number of molecules present in 2 liter of oxygen gas at STP. So this is the question. So here also, if you look, what are the 2 terms we need to find out to find the relationship? So here if you see, calculate the number of molecules. So surely one term is number of molecules present in 2 liter of oxygen gas. So that means it is a volume that is mentioned here. And who is the person, who is the element mentioned here? Oxygen gas. Correct. So I know the fundamental relationship, so I will start from there. 1. So I know that between number of molecules, so I know that 6.023 into 10 power 23, what molecules it is? Oxygen. So I can say O2 molecules equal to, so we can say it is as occupy, since it is volume, will occupy 22.4 liter at STP, since it is mentioned very clearly at STP. This is mandatory. Clear? Now the question here is, are they asking you to find, okay, what is given here, which one you need to find out? Calculate the number of molecules. So this is what you need to find it out. And what they have given here, they are asking you to find out from in 2 liter of oxygen gas at STP, how many molecules are there. So this is 2 liter at STP. Okay, now how we can do this? Again, same concept only. So I can say like, how you can convert 22.4 liter to 2 liter? You can divide by 11.2, right? That is the easiest way I can say. Or if you are not knowing it is 11.2, what you should do? Make this to 1 liter, then multiply by 2 to get the 2 liter. We will do in that classical approach. Okay. So to make this 1 liter, what should I do? Divide by 22.4. So if you are dividing on the RHS by 22.4, divide on the LHS also by 22.4. Correct. So when you are dividing, this will become 1 liter at STP. And if you are dividing here, this will become, okay, for convenience I am taking this value as Avogadro number. You know, right, it is Avogadro. So I am putting Na by 22.4 molecules of O2. Now, are they asking you to find in 1 liter? No, they are asking me to find in 2 liter. So what should I do? Multiply by 2 to get it converted to 2 liter. So multiply by 2. So this will become 2 liter at STP. So when you multiply it on the RHS, also multiply the same thing on the LHS. So this will become 2Na by 22.4 molecules of O2. Okay, now how you can simplify this? You can simplify this by cutting this and this, so that this will become what? Na by Na by 11.2 molecules. So this is the answer. So sometimes they can give it like this, Na by 11.2. Sometimes what they will do, they will put instead of Na 6.023 into 10 power 23 divided by 11.2. So what I will do is I will approximate 11.2 to 10 and I will cut it and I will say approximately 6.023 into 10 power 22 will be the answer. I'll look into the options and find it out. This is for entrance, okay. But for your school exams, what you do is you substitute here, do the actual calculation and find it out, because you can't approximate it there, because stepwise they are giving marks. Okay, so I hope you understood the concept and how to do this. Okay, so we will try to put the next question out of the same relationship and try to do it. Okay, so please go through the next question. The question states that calculate the volume in liters occupied by 18 into 10 power 23 molecules of oxygen gas at STP. So this is the question. Again, please see the linkage. So here volume is one term that you need to find it out, and the other one is the number of molecules. So the number of molecules, it is there and the volume is there. So this is saying the relationship. The same relationship we need to use it here also. And you need to understand here what is given here and what you are asking you to find out. They are asking you to find out the volume. So it is the right hand side you need to calculate, and what they have given here, the number of molecules. The number of molecules they have given here is 18 into 10 power 23 O2 molecules. Correct? Okay, so that means they are asking you calculate the volume that is occupied by 18 into 10 power 23 molecules of oxygen at what condition? STP. Please always look for this. Very, very, very important. Okay, so now tell me how to convert this number to 18 into 10 power 23. Classical method states that first divide by the same number so that you will get 1, then multiply by 18 into 10 power 23 to get the value. But easiest way is look out, is it a straight relationship? Both are 10 power 23, correct? Okay, so here 6 and here 18. So what should be multiplied with? Into 3, correct? So approximately I can say when you multiply by 3, this will get converted to this one. So if you are doing it on the LHS, do the same thing on the RHS, multiply by 3. So the answer will be 4 into 3, 12. You can put the dot. 3 into 2, 6, 7. 3 into 2, 6. So I can say the answer is 67.2 liter at STP. So this will be the volume of the oxygen gas at STP if it has 18 into 10 power 23 oxygen molecules. Okay, so I hope you understood the relationship between the number of molecules and molar volume at STP. So the number of molecules also we tried to link with every term. That is also now over. What is the third term to be linked? That is the molecular mass or the mass in grams. That needs to be linked with what and all things? Mass in grams needs to be linked with first one, the number of gram molecules. Correct? Then mass in grams needs to be linked with molar volume at STP. Already mass in grams with the number of moles and number of molecules we have completed. Okay, so we will next discuss the questions derived out of those two. Okay students, so you could see here questions, next section is questions derived out of mass in grams and the number of gram molecules. Okay, so we will read the question and from that we will try to understand the question and solve it. Okay, so here calculate the mass in grams of 5 gram molecules of nitrogen gas. So nitrogen gas they are mentioning it, so I know it is molecule. Okay, so what is the relationship between mass in grams and gram molecules? I know that molecular mass in grams. So here nitrogen gas, so I know it is N2, that will correspond to 28 gram. Nitrogen atom 14 gram, so N2 means 2 into 14, that is 28 gram. This is equal to, how it is related to gram molecules? I know this is equal to 1 gram molecule. 1 gram molecule of N2 gas. Correct. Now they are asking calculate the mass. So this part they are asking. of how many gram molecules? 5 gram molecules. So this is given 5 gram molecules of N2 gas. Okay, so it's again an easy question. So tell me how to convert 1 to 5. Multiply by 5. So you can directly multiply by 5. So similarly, how you can do this? When you multiply 5 on the RHS, do the same thing on the LHS. So what will be the answer? 28 multiplied by 5 grams of N2 gas. So tell me what is 28 multiplied by 5? So I can say 140. Okay, or easily we can say 30 into 5 is 150. Then 2 should be, you should reduce. So 2 into 5, 10. You subtract it, you will get 140. You can do like that just for your understanding. So I can say this is equal to 140 gram. So answer is what? 5 gram molecules of nitrogen gas will have a mass of 140 gram. Okay, nitrogen gas. So we know that one more question can be derived out of this. So we will do that question next. So hope you could see the question. So I'm just reading the question. Listen. Calculate the number of gram molecules of nitrogen gas present in 5.6 gram of nitrogen gas. So here mass they have given. Okay. So they are asking you to calculate the number of gram molecules present in how much gram of the gas? 5.6 gram of N2 gas. So corresponding to this, what is the number of gram molecules? So this is the question. So what should be done? Do we need to do it in indirect way? Very simple. What is 28 into 2? I know it is 56. Okay, so if you do it here, you should multiply it here. Correct. And what is 28 into 0.2? 28 into 2 is 56. So 28 into 0.2 means 56. Then one decimal left. So it becomes 5.6. So I can easily understand that it should be multiplied by 0.2. Okay, I am telling this out of my practice. Okay, so if students, if you are not able to get that, don't worry about it. Convert 28 gram to 1 gram. How you do that? Divide by 28. So do the same thing on the RHS. Once it is converted to 1 gram, then multiply it by what number? 5.6. Do the same thing on the RHS. You will get it. So every time I am not following it, I want students also to think like this. We know 28 into 2 is 56, but here 5.6 is given. So 28 into 0.2 will give you 5.6. So the same thing I am going to do it on the RHS also. So multiplying by 0.2. So I will get 0.2 gram molecules of N2 gas. Okay, so my answer is 0.2 gram molecules of N2 gas. So I hope this is clear, and with this relationship we have derived the two questions out of it. So we will go to the next question derivation. So we will discuss the next two terms. So listen here, the questions derived out of mass in grams and the molar volume at STP. So you know that here also what we can do, two questions can be derived, correct, which will have mass and molar volume. Okay, so we will go through the first question. So what is the first question? Calculate the mass in grams of 1 liter of ozone gas at STP. So what is ozone gas? O3, you know that, right? So ozone gas means again it is a molecule, ozone, which is formed out of 3 atoms of oxygen, correct? So tell me the mass in grams is the first term to be linked with 1 liter. So it is the volume. So mass in grams with the volume. So we know the fundamental relationship with the mass in grams and volume. So what is that? Mass in grams I can write molecular mass in grams. So here what it is? Ozone gas. Ozone means O3. So it will have a mass of how much? 16 into 3, that is 48 gram. Correct. So this will occupy a volume of how much? We know standard at STP, standard volume, always it will be 22.4 liter. If it is in ml, multiply by 1000. Okay, at STP. That is very important. Standard temperature and pressure. Now in the question, what is given or what they are asking for? They are asking for mass. So here the question will come out, and they are asking you to find out this in 1 liter at STP. Okay, so tell me how to do this. Very simple, you need to convert 22.4 liter to 1 liter. For that, what you should do? Divide by 22.4. So I will divide here by 22.4, then this will become 1 liter. Do the same thing here, so that what will happen? Divide by 22.4. So what happens to here? 48 divided by 22.4 gram. So I got the answer. So I just need to make it a little more simplified. So I can say I can cut this with the 24 and this will become 11.2. Super. Then still I can cut with, so this will become 12 and this become 5.6. Correct. So I can say 5.6 into 2 is approximately how much? You can take it out to 12, 11.2, just now we done. So I can say it's 2.1 something around there. So my final answer is some 2.1 gram. Okay, always round it about 2, then check for the answers in the options. So it is 2.1 gram, that is 1 liter of ozone gas at STP will have a mass of 2.1 gram, and if you take 22.4 liter it will have a mass of 48 gram. That is the meaning actually. Okay, so I hope the calculation part and the understanding part is clear for you. So we will derive the next question out of this. Okay, so the next question you could see here. Calculate the volume in liter occupied by 96 grams of ozone gas at STP. So from this you could see here they are asking to calculate the volume. So I can put the question mark here, and they are asking you to calculate the volume of how much? 96 grams of ozone gas. So here they are telling 96 gram of O3 gas. Okay. Now you tell me how to convert 48 to 96. So you know that it is 48 into 2. Okay, that is for simplicity I am putting these values. But actually what is the classical method? Convert this to 1 gram. How? Divide by 48. So it will become 1 gram. So do the same thing on the right hand side. Then multiply by whatever value. When it becomes 1, it can be converted to any value by multiplying with that value. So here it is 96 means multiply by 96 on the LHS. Do the same thing on the RHS also. That's it. So here I am directly multiplying by 2. So you will get 96 gram. So if you are doing it on the LHS, do the same thing on the RHS. So this will become 44.8 liter at STP. So now I can say 96 gram of ozone gas will occupy a volume of 44.8 liter at STP, or sometimes they will give in milliliter. In that case, what will be the answer? 44800 ml at STP. Okay, that is also correct, because the answer liter is converted to ml by multiplying by 1000, because 1 liter is 1000 ml. So I hope you understood this concept and the questions derived out of mass and volume at STP. Now I think with the mass also we completed everything. Now what is remaining is with the number of gram molecules should be related with volume at STP. That will be the final one. So dear students, so we are coming to our last section, that means in mole concept in terms of molecules. So we have only 1-2 terms to be related, rest all we have done it. So that means around 18 questions we completed. Okay, so that is the questions. Last section is the questions derived out of gram molecules and molar volume at STP. Okay, so here we will also try to do this concept along with a question. So read the question. Calculate the volume in liters occupied by 100 gram molecules of hydrogen gas at STP. So what is the way we used to do it? I hope now you are almost thorough with it. Okay, so the concept is, which are the 2 terms to be related? One is the volume and other is the number of gram molecules. So I know that 1 gram molecule of, what is the gas mentioned here, hydrogen gas, will occupy how much volume at STP? 22.4 liter at STP. This is the fundamental formula, I know. Clear? How I am writing these fundamental formulas? Hope you remember in the first class I am writing all the links, all the relations in one single stretch and taking it in terms of 2 based on the question. Correct? Now, calculate the volume occupied by 100 gram molecules. So, what they have given? 100 gram molecules of H2 gas. Correct? And what they are asking you to find out? The volume at STP. This is what they are asking you to find out. Now, we know the same concept. How to convert 1 to 100? Again, it is easy. Multiply by 100. So if you do it on the LHS, do the same thing on the RHS, multiply by 100. So this will become 2240 liter at STP. So that means 100 gram molecules of hydrogen gas will occupy 2240 liter at STP. That's it. So they can ask with anything. I hope you might be now knowing this. 100 gram molecules or 0.1 gram molecules. Whatever be the case, convert that value 1 to that corresponding value. Do the same thing on the RHS. You will get it. Okay. Now we will do the next question out of the same relationship. So I hope you are able to. We will go through the next question. You are able to see the question now. Calculate the number of gram molecules of hydrogen gas present in 89.6 liters of hydrogen gas at the STP. So they are asking, if you are given 89.6 liters of hydrogen gas at STP, how many gram molecules of hydrogen will be present in that? Okay. So they are asking you this part, the number of gram molecules. This is what they are asking you. And they have given, like they are asking you in how much liters? 89.6 liters at STP. Now, you can itself think how you can convert 22.4 liter to 89.6. The fundamental method, again I am saying, convert this to 1 liter. How you can convert that to 1 liter? Divide by 22.4. Do the same thing on the LHS also. Then once it gets converted to 1 liter, then multiply by 89.6. So do the same thing on the LHS, you will get the corresponding answer. But here you can see, learn some multiples out of 22.4. This will help you surely. I know that 22.4 into 2 is 44.8. And 22.4 into 3 is how much it will come? It will come around 12, 3 into 2, 6, 7, then 3 into 2, 6, 67.2 liter. And 22.4 into 4, it will become, if you multiply by 4, 4 into 4, 16, 1, 4 into 2, 8, 9, 4 into 2, 8, 89.6 liters. So I can say that this is multiplied by 4, so that this becomes 89.6 liters. So here also it should be multiplied by 4, so that this will become 4 gram molecules of hydrogen gas. Okay, so I got the answer. How calculate the number of gram molecules means how many are there? 4 gram molecules are present. So I think with this we have done all the linking. So we derived around some 20 questions and we done it. So all these questions just for your understanding, to make how to read the question, how to find the answer for that, and how to understand. That is what I have explained throughout the session. Now we will do 2 questions or some questions from that came for JEE or Neet, to make you feel comfortable that you have learned this. Question will come from only this actually. If it is from mole concept out of molecules, that means only from this the questions will come. The numbers may vary. Okay. Now we completed mole concept in terms of atom and mole concept in terms of molecules. Little more is there, I will come to that. Before that, we will do some exercise questions from previous exams. So students, we will do that question. So this question came for JEE in 1979. Okay, it's old question. So I have taken it just for your understanding. Okay. So read the question. The largest number of molecules is seen in. So you are given 4 options. In these 4 options, which one will have the largest number of molecules? So here you are going to do, first of all we will analyze, or I will tell the shortcuts also along with that. We are going to analyze, we are going to compare the 4 options. So, and they are asking the largest number of molecules. Okay, the number of molecules is what they are asking you to calculate. And what they have given in the 4 options, in the first option they have given mass, second option they have given mass, third option also mass, and fourth option also mass. So which 2 terms you need to relate? Between the number of molecules and mass in grams. And please understand, whenever number of molecules is asked, in board exams you can substitute exactly 6.023 into 10 power 23, no issues. But whenever there is a comparison is being made, that out of the 4 options which one is having largest, like that, so never use 6.023 into 10 power 23 there. That will make your calculation bigger. Instead use Avogadro number Na, both are same, you know. Instead you put the symbol Na. Okay, so we will try to do this. So first we will try to write the fundamental relationship. What is the fundamental relationship? Na, that is Avogadro number of molecules. Na molecules will have a weight of molecular mass in grams. Molecular mass in grams. Now we will take each option and try to find it out. So first one they have given is water is the first option they have taken. So again, how it will become? It will become Na molecules. I am taking option A. Na molecules, because anything means it will be Na molecules only. So Na molecules of water. And what is the molecular mass of water? You know that H2O. So 2 hydrogen, 2 with 16, 18. So I can say 18 gram. So this is my fundamental relationship. And they are asking you to find out in 36 gram of water. So that means they are asking you this, and they have given here 36 gram. Correct. So what to do to convert 18 to 36? Multiply by 2. So do the same thing here. Multiply by 2. So my answer is 2Na. Sorry, A should be capital. 2Na. Clear? Okay, so it is becoming 2Na. So it is indirectly meaning 2 into 6.023 into 10 power 23. So I will note down here. So this one I calculated it and I found it as 2Na. Okay, this one then I will rub. So this I have noted down as 2Na. Clear? I calculated it. So the next option they are telling is 28 gram of carbon monoxide. So here also what they have given. So I can write Na, option B. So I am saying Na molecules of carbon monoxide, and that will be weighing how much? Molecular mass in grams. So what is the molecular mass of carbon monoxide? 60. Carbon it is 12 and oxygen it is 16. So 16 plus 12 it will become 28. So I can say it is 28 gram. So this is my fundamental formula. Now how much they are asking you to calculate? Fortunately they are asking you to calculate the 28 gram only. So we know that 28 gram will contain how many molecules? Na molecules, because that is a fundamental thing. So I calculated that as Na. So that is now done. Now we will take the third option. That is the third option, 46 gram of ethyl alcohol. So again I can say Na molecules of ethyl alcohol, that is C2H5OH. So tell me what is its molecular mass? C2, 2 into 12, 24, 24 plus 5, 29, plus 1, 30, 30 plus 16, 46. I can say 46 gram. Okay, so this is my fundamental thing. So what they are asking you to calculate, here also they are asking you to calculate 46 gram. So that means 46 gram will contain how many molecules? Na molecules. So here also it is easy. They are not changing it. So it is Na. Okay, now the last option, 54 gram of N2O5. So here I am removing this and putting This is option D. Option D I am calculating. Option D, it is N2O5. So tell me, what is the molecular mass of N2O5? Nitrogen, you know the mass is 14. So 14 into 2, 28. 28 plus oxygen 16 into 5. 16 into 5 means how much it will come? 80. 80. Okay, so 80 plus 28 means how much it will become? 80 plus 28, 108. So I can say this will have a molecular mass in grams of 108 gram. But here, have they given 108? No, they are asking you to calculate the number of molecules in 54 gram of N2O5. Now tell me what they have given here. 54 gram. And you need to find out in 54 gram how many molecules are there. So 108, you know it is Na molecules. So how to convert 108 into 54? Divide by 2. Or again you can use the fundamental stuff, that is convert this to 1 gram, then multiply by 54. Converting this to 1 gram means divide by 108 on both sides, then it becomes 1 gram, then multiply by 54 on both sides. But you know 108 divided by 2 is 54. So do the same thing here, divide by 2. So this will become what? Na by 2 molecules of N2O5. So I got 54 gram. How much it will contain? Na by 2. So right now I have calculated for all the options. Okay. So now tell me, what is the answer? Largest number of molecules is seen in which one? We know that here only, because here it is 2 Na, that is 2 into 6.023 into 10 power 23. That is, you are getting 12 into approximately 10 power 23 molecules. Correct. Here everywhere it is, here what you are getting, 6.023 into 10 power 23 molecules. Here you are getting same thing. Here you are getting divide by 2. That means approximately 3 into 10 power 23 molecules. So what should be the answer? My answer should be option A. Understood? So I hope you got a fair idea how to do this. I have done in a large number of steps. Actually these things are not required. You can just think water means 18 gram. Water has a molecular mass of 18 gram. I know 18 gram has Na molecules. So 36 gram means 18 into 2. So it will have 2 Na. That's it. Carbon monoxide 28 grams. So it will have molecular means, exactly they are asking the molecular means, that will have Na molecules. That is a fundamental relationship. And here also ethyl alcohol, on calculating I understood 46 gram, then it will also have Na. Then this I got it as 108 and they are asking 54, half of it. So it will be Na by 2. So I can easily take option A as the answer. So this is just for your understanding. You are just now stepped into 11th standard. So please do writing. You write it as many times and learn this. After that this becomes a cakewalk. Okay. So thank you for your patient listening. Please learn well, write down the notes and try to do as many questions. Okay, thank you.